LiDAR viewer, it's called LiDAR viewer because most of the point cloud data we get comes from LiDAR machines, although that's changing a little bit, and we'll maybe show a couple examples of that. Next, please. All right. As with Rui, LiDAR viewer itself was written by Oliver. It's one of the tools that you can kind of download from his Rui webpage. And so here he is working with different domain scientists, but really initially this scientist from the U.S. Geological Survey. And there were a couple of important data sets that he worked with. One was looking at this difference in landscape between before and after an earthquake that hit near Parkfield, California. And so here you can see here they're capturing LiDAR, and that sign that's right on the San Andreas Fault. And basically what they do is, look for structures that you can measure where they are here and then measure where they are there and see what they were different. Of course, you have to have taken a LiDAR scan before an earthquake happened, so you have something to compare against. Next, please. Right, so he's looking to measure structural displacements like that bridge. How much did that bridge get affected by the earthquake? Or he had another example where there was a house, there had been a mudslide, the earth beneath the house, or half the house, washed away, so the house is now sort of teetering over a cliff. And they wanted to see how much this house was moving on a day-to-day basis. And so he would go out, put a LiDAR stand off actually on a pier, and take a scan every day so he could measure how that house moved. And so one of the things he did then was there were some reference points that weren't moving, something in the distance that he knew exactly where it was. And then he would measure basically the corners of the house, and he could measure a lot of the points, and from the points derive a plane, a mathematical plane, and then he would do that for one side and the other side, and then he could know exactly where this line was. That's the intersection of those two planes that come together at the corner of the house. And so even though LiDAR points, when they come back, they tend to be pretty noisy. I mean, within millimeters or so, but fairly noisy. You don't know that you're getting precise thing. But in the aggregate, if you take a whole, several thousand of them, average them together, you actually can get very fine, precise measurements. And so sub-millimeter measurements. And so you can see how much this house is moving on a sub-millimeter basis relative to some other fixed point that you assume is not moving on a day-to-day basis. And so, again, he's got this process. He collects these points, these LiDAR scans. He goes to his desktop, and now he has to select, well, which points belong to the wall of the house that I'm going to make a plane out of, right? And so this was one of the things they felt was very, a very obvious thing, that if you could just do this in 3 space with the ability to rotate, it would be a lot easier. Next, please.
Bill, we found our university researchers, they love three-dimensional viewing of LiDAR.
Right, just the viewing, not even doing anything else with it, but being able to put yourself into that space. Yeah.
The data is naturally 3D, and it's terrible looking at it on a screen. 2D screen is really hard.
Right. Yeah, and we'll have a few data sets people can come up. Right, so another thing is LiDAR tends to return lots and lots of points. You can control the LiDAR device so it can scan quickly and give you, a few tens of thousands of points, or you can set it to be very fine and gather millions and orders of magnitude larger collection of points. And so the reason this is sort of its own special application versus using some other desktop tool and expanding VR is because VR needs this real-time flow, right? We need to have frame rates that are, above 12. It's reporting over 200 for this data set, which isn't a big one. And we need to have that. And so by writing his own application, Oliver could load data in, and you'll see this as we go. You'll see data gets loaded in as you get closer to it. And so it's doing this kind of level of detail rendering. And you can choose how you're going to render it. There's a native intensity value, which is what we're looking at here. Sometimes there's kind of a native RGB, which is really photographically determined and augmented onto the points. And you can also select other things like color it by how far it is away from the viewing point. All right, and so one of the things we're going to show is you can paint to select a collection of data sets. This is really what this U.S. Geological Survey scientist was looking at doing. And again, from the aggregate, you can get these more refined measurements. Next, please. All right, so this is what LiDAR is. Really, it's returning an intensity. It also returns a time of flight, which kind of is a distance measurement. And then if you get RGB color, it's really measured separately through a camera and then kind of added on to the points. So you can get some mismatches there because they're usually not captured at the same precise moment in time. And then other category or other features that get added in, you'll find in LiDAR data sets are things like categories, although those are of course not determined by the LiDAR device itself. Those are post-processed. Next, please. All right, so why choose VRUI? Well, if you're the person who wrote VRUI, you're probably going to choose VRUI as your VR application. But also, you know, as the person who wrote VRUI, he can more fully take advantage of all the features that are included in VRUI. And if there's features not in VRUI, he can add them to VRUI, right? And so I already talked about why he would write the new application is really using this out-of-core rendering using an octree. Next, please. All right, so let's look at some data here. So again, we've as soon as my tracking comes alive, there we go. Pre-selected navigation, so I don't have to remap all those things that we looked at earlier. So here's a lot of points. Now I've just made it, I'm bringing it close to the face here, and so it makes the stereo harder. So here I can chord and scale it up instead. Oops. Let me fly it away from us. So now I've just made it larger instead of closer, and so we can see the points a little better, and I'll fly it up. Maybe I'll scale it down a little bit, though. Oops, wrong way. There we go. All right, so there's this lake here. This Jenny Lake. Where is Jenny Lake, Eric? All right. And say we want to just sort of measure. We assume that a lake is going to be planar, although there might be waves on it. But we'll use that kind of to determine where the plane is here. And so again, here's my LiDAR viewer application menu. And so it's got some things. It's got some dialogues. So let me show some of those first. So one of the things, if you get so many points that your frame rate is getting poor, our frame rate's now down to 50, we can adjust the render quality, and that'll affect how many points it's going to load in. So now you can kind of see the octree behind it. You can see these lines, and usually you don't see them except for when they pop in and out. And it brings, as you get closer to something or you request higher quality, it fills in more and more of the points, and you'll see the frame rate is dropping. So we're down to 10 frames a second now. So let's bring it back to something a little more natural. Also, if you want to, this isn't a good example. Some of the other examples will show it better, but if you want to you can fill in the details with less points, you can make those points bigger and blockier. All right. And so there's our render dialog. And now the next thing we want to do then is be able to use the paint to select it. So I need a locator. So I've just created now this little paint sphere. That's a little too large, so I'm going to bring up another dialog that's for interaction stuff. And so I can control the size of this sphere, how much I want to paint at a time. That's pretty good. And then, let me bring it close. So now here, see the data needs to be out in space with me, right? We have to actually touch the data and press a button, so it doesn't paint it unless I actually specifically tell it to. So we can paint some of this lake. And then if I accidentally go up the hill here, there's a subtract mode, of course. There we go. And now I can erase. All right, don't need to be too precise there. All right, so now we've selected some points. What can we do with that? We can figure out what the mathematical plane is at. And so I'll bring up my LiDAR viewer menu. And under primitives, I can do an extract plane. And it put this mathematical plane there on it, which is mostly kind of goes into the data. And that data we can write out, and it'll store the precise mathematical numbers for that, or the floating point level of precision. If we want to see some numbers while we're in here, there's a little strike and dip, which is basically the Brunt and compass style thing. And so we can see that it's pretty much orthogonal to up and down, right? I mean, that's pretty close. So that would make sense for a lake. And then if we want to do that, we can erase that selection. We can make another selection. I may be getting ahead of my slides, but that's all right. All right, so that's too close to read. So this is all, of course, if you're wearing the track glasses, it's not as bad on the eyes. Clear the selection. It'll leave the data there, and then we can paint a new selection. Oh, I got to bring it out in space with me, though. So if we want to get, oh, I'm on subtract mode. There we go. So if we want to get, one of these hills here, one of these. All right, so this isn't going to that's not going to map really well to a plane, of course, but we'll do it anyway. So there's that plane, and then we can get the strike and dip for that. And if you have something that curves, which there's not a lot of good curvature in here, you can also have it mapped mathematically to a cylinder or to a sphere. Actually, we can do that with another one of our sample data sets. Oops. I used the right button, it'll work. And so now, it's got some data. Of course, again, like I said earlier, we're not necessarily going to want to do our analysis in here. We want to collect some numbers and then take it back to our office. So it has the ability to save that data out into a file, or it'll actually print it out on the terminal if you're, and then afterwards you can collect that data and then do your actual work. All right, looks like I covered all that. Next, please, Jeff. I may have covered this as well. Next, please. Lighting. So the lighting, I don't know that you guys do much with the lighting. I don't think you do, right? So there is some lighting features in here if you think that that'll reveal something that's hidden in the data, but it's often very difficult. And here's one thing that's kind of strange is the lighting actually affects the menus as well. So we turn on the lighting. So the standard lighting, I guess, does. So here you can kind of, oh, this is for the sun. So the sun lighting affects the menus. So if I change the orientation of the sun, when it's not pointing at the menus, it's a little hard to see what's going on. But here you can kind of, it's kind of a way to scout. So maybe, maybe now we see this kind of ridge thing here that was harder to see with everything, with the sun not as strafing. Right, when it's bright like this, it's harder to see those things. But I think that's probably less used than other features. All right, next, please, Jeff. I don't know how much more we have. Okay, so there's the command line options. Actually, so unlike with Tort, with LiDAR Viewer, it's got its own special data format. So this is because it uses this out-of-core octree rendering. It doesn't want to have to do the processing to make the out-of-core octree rendering every time, so it does it. You can do it once and then just load in the octree afterwards. So generally, you run your data that you've collected from LiDAR in through the LiDAR preprocessor, and then you tell it how many points there are. If you're reading from a file that has like an ASCII list, how many lines to skip, that's the header, and you can just specify the data. And then it'll create a, is this battery low? There we go. It'll create a directory that has an index into the octree and then the actual points. So it saves you, 3 or 4 minutes every time you run it. You don't have to wait 3 or 4 minutes for it to bring up the data. Next, please. All right, and it has a handful of formats that the LiDAR preprocessor recognizes ahead of time. So LAS is kind of a standard LiDAR format. It'll take just binary data that are in these, 4 tuples, X, Y, Z, and in intensity, and so on. Next, please. All right, here's the command to run the preprocessor. So say, for example, this is the output file. Say we just got a bunch of data in an ASCII format, and it's got color data, so it's just got 6 numbers in a row, X, Y, Z, red, green, and blue. This is how much kind of the GPU you want to assign to any portion of the, or how deep you want the octree to go. Next, please. All right, and running it just like, so LiDAR Illuminator is if you want to do the sun lighting, it'll add normals to it. And we had this discussion when we were getting ready. Well, so it calculates the normal basically by doing like little planar analyses of a point and the points around it. But there's an ambiguity of which way is up or which way is down. However, Oliver doesn't care, right? He's lighting it. When you go to light it, you don't care which way the normal is. So I asked him, how do you know which way is up? And he says, I don't know. It doesn't matter. So, so that's the answer to that question. And there's running it. So you just give it the data file, run LiDAR viewer. And then if you want to run it immersively, again, add the root section and give it the format. All right. And then, yes, okay, so again, so this one is the better ability to get. So if you go to Oliver's page, he's got a special LiDAR page. He's got different versions you can download. So when he transitioned about, I guess, 2 years ago from VRUI 1 to VRUI 2, you know, he had the API changed a little bit, so you have to use a different version of LiDAR viewer depending on which version of VRUI you're using. Really, at this point, if you're not already using VRUI 1, there's no point in doing that.
Bill, is there a typo in those versions? 205?
No, there is not. LiDAR viewer, so the LiDAR viewer version number is specifically, this is LiDAR viewer 2.5, and then I think at around 2.7 or 2.8, he switched from one to the other. So 2.10 is, if you get to 2.10, you have to use VRUI version 2.5. And so, yeah, it's VRUI, but LiDAR version 2.5 works with VRUI 1. Yes, I noticed that myself. I thought, did I get that right? Yeah, so good. Ah, there we go. So let me show some other data sets.
Bill, can I mention something on this too?
You certainly may. You can go out and do it yourself.
On this, well,
you want to do it on the Jenny Lake data set?
well, I just wanted to mention that you alluded to this. You said that the data doesn't all have to come from the LiDAR sensor.
It certainly doesn't, and let me show you.
Okay. Well, actually, before you do that, fly out, fly back. I wanted to see what's popping.
All right. So this is not a huge data set, right? So this may be the highest resolution right here. Well, I should make it bigger, though, because it gets to eye strain. I need to zoom it up.
Come on, Eric, give it a try.
Yeah, you do it, Eric.
I don't know. I haven't been trained.
You may have to figure out, yeah. Try and face forward when you're wearing those, though.
Okay. Which button?
So that's the grab, the joystick for flying. Oh, I got the sun like crazy. Yeah. Yeah, so the zoom, I think, is this button and the trigger in that. Yeah, there you go. Right, so this is the difference between, panning and zooming and scaling, right? Is if you just bring something close to your face, it makes the stereo awful. But if it's large and you're inside of it, then you can see it. So can you see people? Is that a person there? And so this is, I suspect, airborne LiDAR scans.
There's a footbridge across this river here, right here.
Oh, yeah.
That looks weird right now.
There's a slide.
Ooh,
there's a
excuse me.
slide lake up one of these canyons. I guess this is that level of detail. As you fly in, you see it kind of filling in, and then you get to the native resolution of the data. We're on this is an exercise program. We're climbing a hill. virtual exercise. There's some interesting thing there. Anyway. then once you get to the top, you can turn around and feel like you've actually, like you've gone somewhere. Anyway, why don't you show your other data set now?
Yeah. You certainly may, but let me show you another data set. Yeah.
Yeah.
But absolutely, Dave, that's the point here. So let's do Crystal Cavern. So you need to scale it up a little bit first, Eric. Come on down, Dave.
Do I need to take off my computer?
No. Yeah, so this is I mentioned this earlier for Vrui. It wants to put all your data right kind of in this volume in front of you. And so it scales the data down to do that, which is not always what you want. So you end up having to reverse that when you get started. Well, exactly. And for a lot of these LiDAR data sets, that's really kind of what you want.
Okay, I'm having trouble with trouble with cording.
Let me try, yeah.
What's the far button? Is the cording?
I think it is, but I could be wrong. No, it looks like you're not getting it. Yeah, it's not that one.
Not that one. Not that one. Does he have a different?
Well,
do you have a different
second one.
Vrui config on this?
No, it shouldn't
on
be.
this particular thing.
No, it's definitely the far one. So
You do it by itself
no,
with the trigger.
yeah. Oops.
No, I can't do that.
So I'm going to try and make this about life size. Oh,
Yeah. This is a recursive cave, kind of cave within a cave.
we made it a little bit bigger, maybe. Except we're still
You're still
not
outside.
in. Yeah, we're in the ground right now. There we go.
I don't remember the point count here.
Yeah, I don't either.
Probably.
All right, Dave,
two or,
you remember?
2 or
You ready?
300 million.
Find your way through this cave. So let me show you actually while we're here. So this thing right here in front of us, this is a LiDAR scanner, right, a total station there. So you'll see those because they had multiple.
That's a marker. That's
Right.
a marker to drive.
Oh, marker for it, yeah. So you can grab it with the trigger.
Oh, okay.
All right, and then the joystick, you can fly it.
Okay.
It's kind of backwards, though. You pull it towards you. And the joystick, you can rotate
What
as
are the
well.
gray areas?
Gray areas is where there's no data,
Okay.
right? So the LiDAR scan didn't hit anything. So you can see, right? So the LiDAR was here, was shot from here, so it has data there. But if you move away from where the LiDAR was, nothing was scanned
They got
there.
the colors from a photo?
Right. Well, the LiDAR device itself can also take photographs. So you're about to go into solid earth. Oh, there we go. So this is where I usually grab it to flatten it out, right? Grab it and make it, yeah.
That's a picture of a guy's head on the ground there. Pick it up and you can see a picture of the guy. Yeah, that's his hat. See his headlamp?
Yeah.
It's upside down. He was laying underneath the scanner.
Some stairs. So a little desk with computer on it, a laptop on it. Anybody else want to try? Not that I want to kick Dave off. You can also, after we're done with the talk and before dinner, you're welcome to come up and stand in line and try any of the day sets. Well,
Seems like a case would be an
right.
interesting one to have a kind
Right,
of,
let's see.
a flashlight metaphor for the lighting.
So here we go. Let me stand by you, utility, pointer, flashlight. The flashlight may not have an effect on points. Doesn't look like the flashlight, but there is a lighting mode, yes. So let me bring up, we'll use the kill zone. We'll get rid of our flashlight. And I need the tool menu, dialogues, render. Oh,
So this one doesn't have normals. So if the data doesn't have normals, then you can't do the lighting.
So the color and lighting is coming all
Right,
from that.
right.
But you could add normals?
You can run it through the LiDAR illuminator, and it would determine normals based on its neighbors.
How do I pick the render settings
So
off? Do I just kill it then or no?
now, this one you just reselect it in the dialog, and it'll disappear. It doesn't have the, yeah, it doesn't have, this is a pre 2.0 version. Or you can put it over here somewhere, and you'll never see it again. I don't know what the rights are on this data set. Eric, do you?
I'll find out.
All right.
I'll find out.
This makes pretty good data.
It does. It's a good question. I don't know. So where is this cave?
Crystal Caves in California.
Northern California?
A giant spider web.
Yeah.
That's actually the gate that kept people from coming in.
Right.
Now this is the air. Now you're outside the cave.
So if you, yeah, if you,
Turn around 180 and go back in.
so it's all the points that didn't hit anything and just went out and eventually hit something, right?
That's the gate. It took the people like 2 nights to scan this. They had to do it during the night because it was a public open cave. Slow down. They're doing a lot of this kind of
All right, well, especially these narrow spaces, it's hard to, right? I mean,
We have a LiDAR scanner on a robot. We can drive robots through like nuclear facilities.
oh yeah.
Scan.
So you could do like a narrow passageway with that.
You can do it
Yeah.
at a higher point than
Right.
robot. This was done with the manual station.
Yep.
Position and then taken out for 10 minutes. Position, taken out.
All right, let me show you another data set, Dave, since nobody else wants to take your place. Let me scale it first before I give it to you. Yeah. So let's see. Oops. No, but we're above it, but yes, we're seeing under the earth as well. So yeah, it's a canyon on the Snake River.
This data has the color out from a camera.
Is this is in Idaho, Eric?
Idaho.
Right. Yep. And so those little dots in the middle of the air, those are actually birds that got captured.
Really?
Yeah. And so here, let me zoom in a little bit more, and then I'll give it to you. So the joystick might be, depends on how you fly things. Different people do it different ways. To me, it's backwards. But so you trigger to grab, and you can orient. And then thumb, yeah, and it depends on the way you point controls it. Yep.
Yeah. I just noticed in this bigger one that there's also a, maybe it's because there's so many points, but there's a little bit of a lag.
Oh yes.
Are these not frame locked together or something on the screen?
Yeah, there is some tearing. Yeah. Yeah, to me it does. Yeah. So there's a couple of bridges. There's a pedestrian bridge, and then what's the other bridge up there?
The
Highway.
Interstate 84.
So yeah, this is the pedestrian bridge here. You can see some pedestrians on it, and there's the highway up there. And actually, if you look around on the edges, you can see some of the total stations
that we're scanning back and forth across. There's one right here. There's a little LiDAR scanner right there. Yeah.
The person with the backpack right in front of you too. There's graffiti on the bridge. You can read. There's a waterfall.
Yeah. So here's where you can lower the rendering quality if you want to keep the frame rate up and are willing to sacrifice some of the data.
I have another question.
Yes.
So this is also like outside of my range of expertise because I don't know LiDAR stuff. So I'm only repeating things that our LiDAR person for they use this in posing.
Okay.
But they work with, let me say, hyperspectral data from LiDAR. And I was wondering how does something like that plug into a system like this that's more based on RGB?
Right. So yeah, I don't think LiDAR Viewer itself, the way it's written now, it only deals with intensity or RGB. Now you could just, I mean, I think you could probably just take your hyperspectral and map it to different colors, right?
We wrote an app that builds hyperspectral.
Okay. Like if you, is that something
But is that a
that you guys
It's
did?
an extension that the LiDAR combination of LiDAR viewer and phone. So one visualizer shows that
So let me bring up the render quality dialog and you can play with that too a little bit. Let's see. So I'm going to put that on the floor or something. So here you can, oops. Good, or go the other way if you're willing to sacrifice frame rate. No? All right.
Give me frame rate or give me depth.
Right. And you can, again, you can increase the points,
Sort of counteract
fill in
the
some
rest
space.
of
Whoops.
that.
Yeah. There we go. Yeah, that was probably too much.
should be a waterfall again. Bill, I think some of the tearing goes away as cache.
Yeah, right, because each processor is determining whether to load in data.
Yeah.
Yep. And then I have two non-LiDAR generated data sets. And I'll show too. Yep. Yeah, no, that's okay. That's what we want. All right, so I'm going to show a couple of.
Tracker.
Oh yeah.
Finder, maybe quad.
Oh, where'd Harry go, or whatever? Is that his name? It is, and the Z. This is Y up instead of Z up. So this data set is from the group that did. I don't know if you're familiar with it, but they collected pictures from like Picasso, and they decided to do like as much of Rome as they possibly could, and then again, used to, I don't know, as much of Venice as they could. So they just took people's photos, they figured out where they were in space based on commonalities in the photos, and then they can unproject it back to points. And so that's what this sort of little subsample is from, where it's just a bunch of tourist photographs of St. Peter's Basilica. And we can, let me scale it up a little bit. And so this is, you know, this isn't necessarily a full, what you could do if you had a lot of deliberate photographs. If you went in and deliberately took a lot of photographs, then I think you could probably do a little bit better job, maybe process it a little bit more.
Yeah, this technique, well, I don't know about the Autodesk, but Microsoft has something that they've put online. It's on the same group. The group that came up with it did some projects for Microsoft, and Microsoft put it on the web. And then they also did projects for Google, not at the same time, so Google has a feature that you can get to as well. Okay. Yeah. So anyway, so this is non-LiDAR generated. And then we have one other non-LiDAR generated data set. Whoops. Oh, there we are. And this is Dave. Yeah. Yes, that would be very meta if we had Dave demoing, right? So this is just a Connect scan from our building in Bloomington. And what's that in front of you there, Dave? Oh, that's a table, right? One of those desk things. Huh? Yeah. So this was just one of our students, or I guess employees now. Just was taking a Connect with a laptop and scan Dave there. Yeah, I don't know. What are the Connects here used for, Jeff? Student projects, yeah. So here we can actually maybe do one of those features we didn't do before. And that is, let's, what I want, the dialogue for interaction. And I'll make a locator. That's too big. So we'll paint, whoops, that's too small. We'll paint Dave's head here. Oops. And we'll see how spherical it is. All right, so now if we bring up, oops, the sphere primitive, extract sphere. Oop. There we go. So it mapped a sphere as best as it could to this, you know, semi-curved space. All right. All right, so that's it for LiDAR Viewer. And again, for those of you who are too shy to do it during the talk, you can do this between talks and dinner, and breaks and stuff like that too. All right.
I was going to mention something about LiDAR Viewer.
You want a microphone?
No.
I happen to have one right here.
I think people will probably hear me, but maybe not.
I think if it beat on it, it turns it on. I see a red light, so. All right, just yell it.
We had a LiDAR salesman come in from Pharaoh, and I had him scan the actual VR theater here.
Oh yeah, I should put that up too.
It was a great result, because then I wanted to take that LiDAR data set, bring it in here, and see how well it mapped to the VR theater itself. And after I did it, I discovered that our 30-degree mode was actually not 30 degrees. It was 31 degrees and 29 degrees over here. So I had to go back and do it.
Oops.
Not that anybody ever noticed.
Right.
I just thought that was interesting. It is.
Well, so it's generated from a Connect, not a LiDAR scanner. Well, so I don't know.
There was an XYZ.
Right. Did you do this data, Dave, or did Patrick do it?
No, I just had
Right. Yeah. So yeah. So Patrick, one of our guys, you know, just had it generate XYZ locations in RGB, right? And then we just ran it through LiDAR preprocessor, and that, you know. That I cannot answer. Dave, do you know what software he used for the Connect scanning? Yeah, I can ask him. We can mail him.
Well, we were exploring it for, scanning an option too, right?
Right.
So we do a fair amount of digitizing here. So Jeff does that. You guys will see some of that tomorrow during the break, but to scan heads and such, can we scan them? No, for window.
Yeah.
So you can actually use the order from, I think you use the loop with the I found a couple videos where people doing like all this shit. They're just like looking at Connect, they're just walking around, a room, and then all of a
Right. Yeah, and so in that data we can just bring right into LiDAR viewer, and the more resolution you collect, the better the space, the more realistic it looks. All right, can we return to that other slide set that we were in the middle of? Thank you.